Good morning, students. Welcome to the class. This is a special class for the students who are preparing for IIT-JEE and also the EAMCET. Here we solve some problems. The very first problem. If the sum of the roots of the equation ax square plus bx plus c is equals to 0 is equal to the sum of the reciprocals of their squares, then a by c comma b by a comma c by b are in here the given equation is ax square plus bx plus c equal to 0. Let alpha comma beta be the roots of this equation. So sum of the roots alpha plus beta is equals to minus b by a, and product of the roots alpha into beta is equals to c by a. So these are the known facts. So solution. Let alpha comma beta are the roots of the equation ax square plus bx plus c is equals to 0. Therefore, alpha plus beta sum of the roots, which is equals to minus b by a, and alpha into beta product of the roots is equals to c by a. So here sum of the roots alpha plus beta is equal to the sum of the reciprocals of their squares. So therefore alpha plus beta is equals to 1 by alpha whole square plus 1 by beta whole square. So reciprocal of alpha is 1 by alpha, reciprocal of beta is 1 by beta. So sum of the roots is equals to sum of the reciprocals of their squares. So this implies alpha plus beta is equals to alpha square plus beta square by alpha into beta whole square. This implies alpha into beta whole square into alpha plus beta is equals to alpha square plus beta square. So this is equals to alpha square plus beta square in terms of alpha plus beta is alpha plus beta whole square minus 2 alpha beta. So substituting the values Here alpha beta, which is alpha into beta is c by a. So c square by a square, c square by a square into alpha plus beta, which is minus b by a, minus b by a, is equals to alpha square plus beta square in terms of alpha plus beta, which is so b square by a square minus 2 into c by a. So this implies minus bc square by a cube is equals to b square a minus 2a square c by a cube. So this implies a cube get cancelled. So this is b square a plus bc square is equals to 2a square c. So this implies ab square plus bc square by 2 is equals to a square c. So this implies ab square comma a square c comma bc square are in AP. Now dividing the terms by ABC, dividing by ABC, this implies AB square by ABC comma a square c by ABC comma bc square by ABC. This implies b by c and this is a by b and this is c by a. This is in AP. So reciprocals of the terms in AP is HP, harmonic progression. So this implies a by c comma b by a comma c by b are in harmonic progression. Next, second problem. Second problem. The ratio of the sum of first three terms to the sum of first six terms of a geometric progression is 125 is to 152. Then the common ratio of common ratio of the GP is so here geometric progression. So the general series, the general sequence of the geometric series. So solution AR square dash dash AR to the power of n minus 1 dash dash. This is geometric progression with the first term A and common ratio R. Since the sum of the first n terms, of this GP is Sn is equals to A into 1 minus R to the power of n by 1 minus R. Here sum of the first three terms. So n is equals to 3. This implies S3 is equals to A into 1 minus R cube by 1 minus R. Again, sum of the first 6 terms. N is equal to 6. This implies S6 is equals to A into 1 minus R to the power of 6 by 1 minus R. So now consider the ratio of S3 and S6, which is given by 125 is to 152. So consider S3 by S6, which is equals to 1 minus R cubed by 1 minus R to the power of 6, which is equals to, this is 1 cube whole square and this is R cube whole square, A square minus B square. So get cancelled. So this is 1 by 1 plus R cube. This is given as 125 by 152. So this implies 1 plus R cube is equals to 152 by 125. This implies R cube is equals to 152 minus 125 by 125, which is equals to 27 by 125. This is equals to 3 by 5 whole cube. 3 by 5 whole cube. So R is equals to 3 by 5. R is equals to 3 by 5. The common ratio of the GP is R, that is equals to 3 by 5. Next, third problem. Third problem. The range of y such that the equation y plus cos x is equals to sin x has a real solution. Here the trigonometric equation is y plus cos x is equal to sin x, and x belongs to the set of real numbers. solution y plus cos x is equals to sin x. This implies y is equals to sin x minus cos x. This is equals to multiplying and dividing by root 2. So this is sin x into 1 by root 2 minus cos x into 1 by root 2. So here cos 45 degrees is 1 by root 2, sin 45 degrees is 1 by root 2. So this is equals to root 2 into sin x into cos 45 degrees minus cos x into sin 45 degrees, which is equals to root 2 into sin of a minus b, sin a cos b minus cos a sin b. So into sin of x minus 45 degrees. Here we know that sin theta always lies between minus 1 and plus 1 for theta belongs to the set of real numbers. So range of y is equal to root 2 minus root 2 comma root 2. Since minus 1 less than or equal to sin theta less than or equal to 1 for theta belongs to the set of real numbers. So this is sin theta, which lies between minus 1 and plus 1. So minus root 2 comma root 2 is the range of y for the given trigonometric equation which has a real solution. Next, fourth problem. Fourth problem. The number of positive integers, the number of positive integers which can be formed by using any number of digits, any number of digits, 0, 1, 2, 3, 4, 5, using each digit not more than once, in each number is So the given digits are 0, 1, 2, 3, 4, 5. So with the help of these digits we can form 1-digit numbers, 2-digit numbers, 3-digit numbers, 4-digit numbers, 5-digit numbers and 6-digit numbers. So what are the total number of positive integers? Here the condition is using each digit not more than once in the number. Here the condition is using each digit not more than once in each number. Then what is the total number of positive integers which can be formed by using the digits 0, 1, 2, 3, 4, 5 subject to the condition. Solution. The given digits 0, 1, 2, 3, 4, 5 are the given digits. So here the condition using each digit not more than once, in each number, So we can form one digit numbers. Therefore, one digit numbers is equals to 5p1. So excluding 0, 5p1. Two digit numbers, which is 6p2 minus 5p1. Three digit numbers, 6p3 minus 5p2. Four digit numbers, 6p4 minus 5p3. Five digit numbers, 6p5 minus 5p4. Six digit numbers, 6p6 minus 5p5. Therefore, total number positive integers is equals to 5p1 plus 6p2 minus 5p1 plus 6p3 minus 5p2 plus 6p4 minus 5p3 plus 6p5 minus 5p4 plus 6p6 minus 5p5. Here NPR is the permutation. The number of arrangements of R objects over N objects taken at a time. So this is equals to 5p1, which is 5 plus 30 minus 5 plus 120 minus 20 plus 360 minus 60 plus 720 minus 120 plus 720 minus 120. So which is equals to 5 plus 25 plus 100 plus 300 plus 600 plus 600, which is equals to 1630, 1630. So we can form 1630 such number of positive integers. Next, fifth problem. Fifth problem. A bag A contains two white, three red balls, and bag B contains four white balls, and five red balls, One ball is drawn. At random and is found to be red then the probability that it was drawn from the bag B is here is the solution. There are two bags, bag A and bag B. Bag A contains white and red balls. Bag B also contains white and red balls. So A, B, white balls, red balls, total. Bag A contains white balls, two white balls, and red balls, three red balls. Altogether, 5 balls in bag A. And bag B contains 4 white balls and 5 red balls. Altogether, 9 balls in bag B. So, here one ball is drawn at random and is found to be red. Then we have to find the probability that it was drawn from the bag B. Probability of selecting a bag. Is equals to P of A is equals to P of B is equals to 1 by 2. Probability of getting red ball red ball from bag A is equals to probability of red A is equals to, so this is 3 by 5. 3 by 5. Probability of getting red ball from bag B is P of R given B is equals to 5 by 9. So required probability using Bayes theorem. So therefore probability of B given R is equals to P of B into P of R given B by P of A into P of R given A plus P of B into P of R given B. So this is equals to P of B is 1 by 2. P of R given B is 5 by 9 by P of A 1 by 2 into P of R given A is 3 by 5 plus 1 by 2 into 5 by 9, which is equals to 25 by 52. 25 by 52. Next, sixth problem. Sixth problem. A speaks the truth 75% of cases and B speaks 80% of cases. The percentage of cases they are likely to be contradict each other, in stating the same fact, is Here is the solution. Probability of A speaks the truth is 75%. So probability of A speaks truth. A speaks truth is 75 by 100. This implies probability of A will not speak truth, which is probability of A bar, which is equals to this is P of A 25 by 100. Probability of B speaks truth. B speaks truth is P of B is equals to 80%, 80 by 100. This implies probability of B complement is 20 by 100. Then we have to find the probability that they are likely to be contradict each other in stating the same fact. Contradict. So, which implies probability of contradict, probability of contradict is equals to P of A into P of B bar plus P of B into P of A bar. So this is equals to P of A, which is 75 by 100, P of B bar, which is 20 by 100, plus P of B is 80 by 100, and P of A bar is 25 by 100. So this is equals to 35 by 100, which is in percentage 35%. So these are some important problems which are useful for observation as well as for practice of the students, those who are preparing for IIT, JEE and EAMCET. So with this we conclude this class. We will meet again in the next class.